Hello and good day, everyone. My name is Muhammad Afiq bin Muhammad, context number 2060003. So today, me and my group are going to present about the bomb calorimeter, the calorific values of solids. So before we proceed, let me just give you a short introduction of our topic. So we must first understand what is thermal analysis and calorimetry. So for thermal analysis is a method used to measure properties of a material at different temperatures. So these properties can be as a function of temperature, including volume, mass, dimension, optical properties, gaseous decomposition, products, heat differences, and temperature differences. So to perform a thermal analysis, both the temperature and the sample environment have to be controlled. The temperature is suddenly increased or decreased, and tests are done at a series of temperature points to see if or how a material is changing. So as for calorimetry, it is used to measure the heat released into or absorbed from the environment during a chemical reactions. So calorimetry can be divided to three main classes. There is isothermal. So isothermal is which uses a heat sink to keep the reaction environment at a constant temperature as the reaction occurs. And then there is adiabatic. So adiabatic allows reactions to change the environment, and the change in temperature is measured as time goes on. And finally, for temperature scanning, which this process requires the increase in the temperature of a sample being tested and a reference sample as it is determined. So next, I will introduce what is a bomb calorimeter. So bomb calorimeters are used to precisely calculate the energy shift that occurs during the reaction. The original Berthelot calorimeter, it was developed into the contemporary bomb calorimeter. So the combined bomb calorimeter of today is constructed of corrosion-resistant steel. The bomb calorimeter is a device that measures the heat of reaction at a constant volume as well as the heat that is measured, which is known as the change of internal energy. So the bomb calorimeter is a type of constant volume calorimeter used to measure the combustion heat of oxygen burnable materials. The specific type, which is the oxygen bomb calorimeter, is a scientific tool used to quantify the heat produced during burning of an excess of oxygen in a sample. So through the use of bomb calorimeter, we can conduct an experiment, and this experiment aims to ascertain the impact of employing the oxygen bomb calorimeter on physics students' capacity for scientific processing. So that is all for this short introduction. Now we'll move on to the operating mechanism of the bomb calorimeter. So as you can see, this is a process of how we conduct a bomb calorimeter. So since it is to determine calorific values, the first step is, of course, to supply oxygen into a valve on top of the bomb. So a bomb is actually a powerful steel shell need to contain the oxygen. So this oxygen will combust the sample that will be contained inside the bomb. So in our test, we'll be using coal, and 2,000 centimeter cube of water will be added later on. And then later, through this combustion, we will also, as you can see in the diagram, there'll be a fuse wire, and this fuse wire will be burnt, meaning that the electric circuit will be cut off after that. So that is just a short procedure of how to conduct this experiment. So that is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Yukmazaman, matrix number 207776. Today I'm going to present about the application of oxygen bomb calorimeter in real life application. So one of the uses of oxygen bomb calorimeter is the procedure of liquid and solid fuel testing. In this procedure, the usage of it is to determine the calorific value of certain fuel in order to be marketed according to their quality and range of usage. For this can be proven, for example, if we go to petrol station, there is a difference of price of RON 97 compared to RON 95. This is because per unit volume, RON 97 can supply and will supply more energy to the car compared to RON 95. So it's vital to set the price differently, and how we can distinguish between these two types of fuel and its energy content is by using the calorimeter to distinguish the two types of fuel to be marketed differently with different price.
Hi, Assalamualaikum. My name is Muhammad Hafsham Shah bin Abdul Razak. My metric number is 205540. So now I will continue with performance analysis of bomb calorimeter. Basically, the heat of combustion of a food or enthalpy of combustion of a food is referred to as the energy content of the food and is provided on the label of packaged food that we buy every day. Basically, the food sample is ground into a fine powder using wheelie mill, and after that, estimated amount of food sample is weighed out, and the sample is placed into the holder and feed it into the pellet press, and then pellet is pushed out of holder, and another reading of the sample weight is taken and record a value, and the pellet is taken out and take to the bomb calorimeter. And then lastly, the data is obtained from the bomb calorimeter. And as we know, there are four essential parts required in any bomb calorimeter. The first one is a bomb or vessel in which the combustible charge can be burned. And second one is a bucket or container for holding the bomb in a measured quantity of water together with a stirring mechanism. And the third one is an insulated jacket to protect the bucket from transient thermal stresses during the combustion process. And lastly, a thermometer or other sensor for measuring temperature changes within the bucket. Okay, now I will continue with second part of the performance analysis. We know that combustion reaction are usually exothermic reaction. So the change of combustion is typically negative. So the bomb calorimeter consists primarily of sample, oxygen, and the stainless steel, bulb, and water, where the wall prevent heat flow from the calorimeter to the surrounding atmosphere. So we have Q calorimeter is equal to 0. And since the bomb is made from stainless steel, the combustion reaction occurs at constant volume and there is no work. So work calorimeter is equals to 0. Thus the change in internal energy, change of U for the calorimeter is 0. Thus, we get that change of U calorimeter is equals to the Q calorimeter plus work calorimeter is equals to 0. And the thermodynamic interpretation of this equation is that the calorimeter is isolated from the surrounding atmosphere. And since the calorimeter is isolated from the rest of the surrounding, we can define that the reactants, which is sample and oxygen, to be the system, and the rest of the calorimeter, bomb and water, to be the surroundings. So the change in internal energy of reactants, open combustion can be calculated from the like in that equation. D delta U total is equal to delta U system plus delta U surrounding is equal to 0. And then delta U system is equal to negative delta U surrounding. And since the process is if constant volume is constant volume, so dV is equal to 0. Thus, recognizing the definition of heat capacity CV yields, du system is equal to negative CV dt. And we assume that CV to be independent of T over small temperature range. This expression can integrate to give change of U is equal to negative CV change of temperature. And by definition of enthalpy, which is change of H equals to change of U plus PV. And there is very little expansion work done by condensed phase, which is change of PV is slightly equals to 0 or equals to 0 for solid and liquid. And we assume the gas to be yield is delta H equal to delta U plus RT and change of number of gas. So to sum up, we can conclude that calorimeter can be a useful instrument for analyzing food or nutrition, and it is a quick method that is mostly used for quality control. And lastly, to calculate the amount of heat or calories in food, the bomb calorimeter are useful such in food testing laboratories and others. That's it from us. Thank you.